Hello everyone. Today we will predict road accident risk from already given data in Kaggle. So this is the link of the Kaggle competition. Let's just see data. So here in training data, uh, columns like road type, we have columns like number of lanes, curvature, speed limit, lighting, weather, road signs, public road, time of the day. So let's just load our data into our Kaggle notebook. First, we will need data cleaning. So we will we'll import relevant libraries like NumPy and Pandas. Let's just import train test plate. And first we will see. Wait a minute. First we will see what exactly is in this dataset. So this we have road type, number of lanes, curvature, speed limit, lighting, weather, road signs, public road. Values like this. These are all our input features from road type to number of reported accidents, and accident risk is what we have to predict. This is our output feature. So let's just see for about our data. So we have total 14 columns in which for us ID is useless. Okay. And we have how 5,17,754 data points. So that's a lot of data points for our deep learning model as well. Whether we have to make a machine learning model or deep learning model, we have enough data. So this we have booleans, object, and integer as well. Okay. So let's what we will do is we will replace this true with one and false with zero. Okay. So we have done that. Let's just see again about our info. Okay. Now we have this road type, lighting, weather, and time of the day. These four columns. We have object data like in road type we have urban, rural, high. In lighting we have daylight, dim. Let me just show. So uh, let's see lighting. So in lighting we have three types, three values: dim, daylight, and night. Now our machine learning models needs a whether boolean data or integer or float data. It doesn't understand object data. So what we will do is we will one hot encode these four columns. That is type, weather, road type, lighting, weather, and time of the day. And we will drop first column because I think when you suppose there is a column named gender, male and female, suppose. So there is no point of making two columns named gender male and gender female. If we only make one column named gender male, that is enough. So we'll one hot encode this, and again we will see info. Okay. Now we have these boolean values, we have this integer value and float value. Okay. Now let's just save this clean data to a file. Well, I've already done this table before. Let's just go into our actual machine learning model. So now here we will input relevant libraries like NumPy, Pandas. We will import features like train test split, and we will import Keras. In it, we will import sequential, dense activation, and dropout. It is taking time. So let's just see data again. Okay, perfect. Okay, accident risk is here. Doesn't matter. No problem. Let's first see are there any null value. Yeah. We have null values that we didn't see before. Okay, last column we have null values. So what we will do is we will drop all the rows that have null values directly. Now we will see is there any null value. Okay, we don't have any null value now. Now let's just select our input features. So for input features, our ID is not needed, and this accident risk is our output feature. So we'll drop these two columns, and remaining will be our input features. Okay, perfect. Let's just see. Fine. Now our output feature. Okay, this Y is our output feature and X is our input features. Let's just see the shape of X. Sorry, let's just see how many columns or input features we have. We have 16 input features. Now, what we will do is split this data into two types. One is training data, testing data. In training data, we will actually train the model, and in testing data, we will use it for evaluating our model. So, what we will do is 80% data will take randomly, and we will train it for our model, and 20% data we will keep it for testing. Now, from here, our actual neural network starts. First, what we will do is make an object of called sequential. Sorry, make an object called model, and this creates a neural network. And after that, we will keep adding layers. So in this, we are declaring this model, and first layer, hidden layer, we are adding, in which our neuron will be as same as x dot shape. So we will have 16 neurons in first layer. Our activation will be ReLU. Input dimensions will be 16. That is number of columns. Okay. Now our first our first hidden layer, we have 16 neurons. Activation is ReLU and input dimensions are 16. Now what we will do is we will add 3 layers, hidden layers with 14 neurons each, and activation ReLU. 2 layers with 8 neurons, ReLU as activation function, and 1 layer with 4 neurons, ReLU as activation function. After that, we will add a dropout layer. This is 0.0 dropout layer, so I don't think that is relevant here. So, okay, no problem. And after that, this is a regression problem. So what we will do is we will give an output layer, and its activation function will be linear. Let's try it. Let's see model summary. Okay, see. Okay, sorry. I have not made a model. Okay, here is our model. So this is our this is what our model looks like. 16 neurons, 14 neurons, 14 neurons, 14 neurons, 8 neurons, 8 neurons, 4 neurons, 4 neurons, 1 neuron. Total trainable parameters 1163. So what it will do is it will create a function of 1163 parameters, and every time it iterates backward propagation. Every time it has backward propagation, it will update all those 1163 parameters. So we basically have a universal function approximator of 1163 parameters in this case that will fit to our data set. So let's just compile our model. In it, our loss function is mean squared error. Optimizer is Adam. Our metrics will be mean squared error. Okay, fine. Now we will fit our model. We will train it using mini batch gradient descent, not stochastic, because we have almost 3 lakh values for training data set. and 50 epochs is fine because our batch is small, 1024, and we will create a validation speed of 0.2. What it will do is it will create two MSC. One is normal, our training mean square error, and validation mean square error. We will by it we can find out is that model overfitting or not. So let's just train our model on 50 epochs. Can already see how unstable our model is. Something clearly is wrong in this model. Okay, what we'll do is we will try. Finally, after trying and testing, we have our validation MSC as 0.0034. So this is our validation loss and validation MSC versus epoch graph. Actually, there should have been two graphs, sorry, two line graphs like this, but one is completely validation loss and validation MSC are almost on top of one another. Therefore, we cannot see the difference between them. Let's just see root means RMSE of this neural network. So in Y prediction, they have already predicted X test, and the root mean square of this neural network for this data set is 0.0584, and this is shape. So this was our test data set. Again, clean. So yeah, basically neural networks are like one layer you will here and there are the output of the model changes drastically. What I only did was from changing 14 here, our initial model had 14 neurons here, neurons or perceptrons, 14 perceptrons here, 8 perceptrons here, and 4 perceptron here. I just changed from 1484 to 864, and that previous model was converging to 0.004. Our new model is almost converging to 0.0033 or 0.0034. So yeah, I give notebook imports of this both the cleaning one and this neural network one by links. Till then, subscribe the channel. Enjoy.